for objects, there's this idea of pointers, what's happening in the physical memory and stuff. So this claymation video I watched, Mr. Simon showed me way back when, and I remember it to this day. Whether or not that was because of the claymation or just the pure content and fun of the video, I am unsure. But here I show it to you. It seems to be a rite of passage of sorts to show this thing when talking about pointers. So first, it's a short video, 3 minutes. I don't think we'll need to watch it twice, but do try to pay attention to what he's saying, and there's going to be little code segments towards the bottom that should be in Java for this class. My block 6, I accidentally showed the C++ video, so let's see what happens. Annotations going. Double check. Oh, this is Java. 1 second. On the Java version, yeah, this one. Alright, and just a quick thumbs up when the video starts playing, just to confirm that there is sound. I think I went through the necessary steps.
Wake up. It's time for pointer fun. What's that? Learn about pointers. Oh, goody. Well, to get started, I guess we're going to need a couple pointers. Okay. This code allocates 2 pointers which can point to integers. Okay, well, I see the 2 pointers, but they don't seem to be pointing to anything. That's right. Initially, pointers don't point to anything. Things they point to are called pointees, and setting them up is a separate step. Oh, right. I knew that. Pointees are separate. So, how do you allocate a pointee? Okay, well, this code allocates a new integer pointee, and this part sets x to point to it. Hey, that looks better. So make it do something. Okay, I'll dereference the pointer x to store the number 42 into its pointee. For this trick, I'll need my magic wand of dereferencing. Your magic wand of dereferencing? This is what the code looks like. I'll just set up the number and... Hey, look, there it goes. So doing a dereference on x follows the arrow to access the pointee. Okay, so store 32 in there. Hey, try using it to store the number 13 through the other pointer, y. Okay, I'll just go over here to y and get the number 13 set up, and then take the wand of dereferencing and just... Whoa! Oh, hey, that didn't work. Say, Pinky, I don't think dereferencing y is a good idea, because, setting up the pointee is a separate step, and I don't think we ever did it. Yeah, we allocated the pointer y, but we never set it to point to a pointee. Very observant. Hey, you're looking good there, Pinky. Can you fix it so that y points to the same pointee as x? Sure, I'll use my magic wand of pointer assignment. Is that going to be a problem like before? No, this doesn't touch the pointees. It just changes one pointer to point to the same thing as another. Oh, I see. Now y points to the same place as x. So wait, now y is fixed. It has a pointee. You can try the wand of dereferencing again with 13 over. Okay, here goes. Hey, look at that. Now dereferencing works on y. Because the pointers are sharing that one pointee, they both see the 13. Yeah, sharing, whatever. So are we going to switch places now? Oh, look, we're out of time. But just remember the 3 pointer rules. Number 1, the basic structure is that we have a pointer, and it points over to a pointee. But the pointer and pointee are separate. A common error is to set up a pointer, but to forget to give it a pointee. Number 2, pointer dereferencing starts at the pointer and follows its arrow over to access its pointee. As we all know, this only works if there is a pointee, which kind of gets back to 1. Number 3, pointer assignment takes one pointer and changes it to point to the same pointee as another pointer. So after the assignment, the 2 pointers will point to the same pointee. Sometimes that's called sharing. That's all there is to it, really. Bye-bye now.
Alright, so that's your video. Language does get a bit heavy, but I hope the diagram makes sense and it was presented in a nice way. So we'll walk through those code segments a little bit at a time. So going back to this idea, you've seen it before. This the difference between double equals and dot equals. Except now we bring the single equal sign into the mix. What is happening there? Is it still doing comparison? Yes or no? So with pointers, the single equals is assigning two pointers to the same object. So that's when he set y equal to x. That made it point to the same 42. If x double equals y, are x and y pointing to the same object? That's like what's happening with the double equals in strings. It doesn't work the way you think it does because it's comparing memory locations. Are they the same object? If x dot equals y, that one works the way you think it does, like it did with strings. It compares the values of x and y. Do they have the same value? Moving forward. This x and y code right now, x and y in these pointer diagrams, I think we have it consistent. X and y are pointers, so they have square boxes. They point their pointees, which are circles, either objects or other kinds of values. Okay. Here, x and y refer to two different objects with the same value, and it should look kind of familiar. So from the Binky video, they walked through the code here. We're going to break it down line by line just to repeat the points and highlight the nuances of what's going on with the pointers, pointees, the magic wand of dereferencing, so on and so forth. Okay, so in the very beginning, they initialized two objects, x and y. You see now another reason why we emphasize those two steps of initialization and declaration. So here is just the declaration. They don't point to anything. If you tried to print it out, this x and y wouldn't return any values. It would probably tell you null. Then they use the new keyword, which is like initializing the x object. But notice it's a call to the default no argument constructor, which contains nothing. So x exists in memory, but it doesn't have a value. This is different than y, right? Y has no pointer at all. At least not yet. It's not pointing at anything just yet. We do x.value equals 42. This is where that magic wand of dereferencing came in. You follow x's pointer, and wherever it lands, you update that value. Next, y.value equals 13. This is the part in the video where, the Binky puts his wand by the y pointer, tries to dereference it, tries to follow the arrow, but since the arrow leads nowhere, they got a crash. And you see this null pointer exception. And now you see why the pointer idea comes. Null means nothing, it points to nothing. Exception, that's the error. So it's really easy to make this mistake. This one, y is now pointing to whatever x points to. Also follow the arrows. And then lastly, they updated y's value since they share that same object in the computer's memory. 13 is what y's value is, and x's value also got changed as a result. There's that idea of sharing, because they point to the same thing. So just as a quick check for understanding, what is the value that is printed? Do type it in the chat. Very good. Show me that you're there and awake. Yes, yes, very good. I should see a spam of a certain number. Very good. So we have a bunch of 13s, and that is correct. 13 does in fact get printed to the screen. Okay, so far so good. Diagrams aren't that complex. And when working with pointers, I highly recommend you draw out these diagrams. When you see initializations like int obj or something, you draw a little box, draw an X there. When they do new, you draw a circle, and then you draw arrows in between these boxes and circles. You should know that only objects have pointers. Java is an object-oriented language. Everything ends up being an object except for those primitive data types like int, double, float, char, and stuff. Everything else are objects, so thus they have pointers. This first idea we'll spend the majority of our slides on. The type of structure shown here only occurs when two pointers are set equal or assigned to one another. The last two slides goes over this idea when pointers are passed into functions. I think this second bullet point is a little bit tricky. So going over the new keyword and some more complex pointer diagrams. Here's some code that should look familiar. We're using the string literal of test. Okay, 1 and 2. And then 3 here uses a new keyword, makes a new string object that contains test, and then we do some kinds of comparisons with the double equals, which compares are they the same object. So it should be no surprise that the first line displays true, second one displays false. If you're unconvinced that these are in fact the outputs, here's a diagram that goes with it. 3 is its own separate object containing that same word. 1 and 2 point at the same thing. And it's a little tricky with strings, although there was no new being called in 1 and 2. The computer's memory does reserve a spot for it. But since it isn't like the new keyword isn't used again, here they point to the same thing. So I'll give you a minute or so. Please work on this practice quiz question and type in the chat your outputs. I'm going to pause my video. When we go over the answer, I'll turn it back on. So video has started up again. So notes, I get what you're saying when you type out the number 1 and the number 3, but they should be the words 1 and 3 spelled out. If you were to say that was the output on like a formal exam, that is totally different and wrong, because the string that contains the number 1 versus O-N-E are different, okay? Common mistake was thinking that the output was 1, 2, and then the second line was 1, 2. I have to think about what was going on in your brain and maybe construct the diagram for that. But let's go over what's going on here. Click, click. Yes, okay. So in the very beginning, we had sum type 1 equals new sum type with a 1 argument constructor. All it does is initialize its string to be 1, its value to be a string O-N-E. The same happens with 2. So in this moment in time, 1 and 2 are pointing to their own words, their own objects, because the new keyword is used. Next, there are two things that can happen. First, up here, sum type 2 equals 3 creates a 3 pointer, and its pointer points to the same place as 2. So running just this line of highlighted code, this box is created, an arrow is made, and This word should be 2 at this moment in time. When we go down here, 3.sMessage equals 3, that's when we override what was inside 2's circle. Because 2 and 3 now point to the same thing, either updates to 2 and 3 will change this same object. And from here, you should see that your first line of output, 1.message is 1, comma 2.message is 3. 1, comma 3, spelled out. Questions at this point in time? Okay. Going on to the next couple lines. Now there's some more reassigning and pointer movement. We change the 3 pointer to now point to what 1 was pointing to. 3.sMessage equals 4. So what was the word 1 is now replaced with the word 4. This is the diagram that matches this system.out.println. So we should see 1.message 4, 2.message is 3. We should see the word 4, comma 3. Okay. So it's important to note that potentially one of your mistakes was like drawing in an extra arrow versus moving the arrow, like erasing it and having it point to another thing. So pointers can only point to one thing at a time. That second use of the magic wand of dereferencing, the equal sign, 1 equals 3, points 3 at the first object, so it no longer points to the second. All right, so questions on that practice quiz question? The next couple slides, a little bit different idea. Ask them now. Okay, none. Let's compare what this pointer idea. How does it compare when we're working with regular variables, primitive data types like ints, floats, doubles, and chars? This use of the equal sign, especially that don't use pointers, works the way you think it does. So here, int n1 and int n2 have the value 3. Changing one doesn't change the other because they're separate memory locations. Or not that, because they're built-in data types. Do they have separate memory locations? I'm unsure. n2 equals 7 just changes n2, n1 remains untouched. So system.out.println here displays 3. You know this example. It's when dealing with objects, right, this new pointer idea comes in. So here, we've just created one object. Really, it's the same picture, right? The code changed a little bit, but the picture is the same. You've seen this picture before. 2 pointers, 1 object. So here, println n1.value at the end should print out 7. Right, so this diagram only matches the highlighted bunch of code. The first 3 lines are reflected in this diagram. Then n2.value equals 7 happens, so it gets overwritten. That's why n1.value, when it's printed, you see 7. Okay. So this last 2 slides, pay attention. Has to deal with arguments, input arguments. So passing an int as an argument makes a copy or duplicate of the int. So that's the local variable idea. Notice here in this example, mystery takes in the value num. Okay, num is initialized in setup. Then when we call mystery, n is a copy of num, so it exists down here. When we do n.2 or n equals 2, this happens, okay? N gets updated, but num remains untouched. So when the first system.out.println that happens inside mystery, we see the number 2 printed to the screen. Then we do the setup's original system.out.println, and we see the number 1 get printed after that. 2, then 1. You see with primitives, like int, float, double, char, changing the copy doesn't change the original. That isn't the case with objects. So that very similar example, but now with objects, notice the difference, okay? You initialize the object A to be a new int object, a.num equals 1, all right? Mystery of A, so this makes a copy not of the object itself, but the pointer, okay? So here in mystery, n, this pointer, is a duplicate of the A pointer, and n.num equals 2 now updates. Green's a bad color there. N.num updates this object to contain the value 2. Thus, in this system.out.println, down here in mystery, you see the number 2, but also A's num is changed. You see the value 2 and 2 printed to the screen. So here the change, because of the pointers, affects both A and N. And I think that is most tricky. So that's it for today's lecture. You will be working on the pointers worksheet tomorrow, no, 2 days, so that's on Friday. We'll take questions from your pointers worksheet. There's also helpful hints in these next couple slides related to your pointers worksheet with nice little pictures. And then whatever time remains on Friday, we have a short quizzes reviewing what we've learned about strings and this new stuff about pointers. There is no further assistance given with Pig Latin in terms of the lectures. Please get that done. If you need help, do message me for office hours, send me an email, and we'll set those up. That's all, Block 1. Take care. You get to go 5 minutes early.